Howdy, y'all. Today, we're going to start over the lesson, and we're going to do Factor and Remainder Theorem. Take it away, Miss McGee. I feel like I have a list. Take it away, Miss McGee.
All right. Okay. Just as a recap, okay, I can always do long division. Synthetic only works sometimes. Synthetic only works when you're dividing by x plus a number or x minus a number, in which case I'm doing here. So opposite sign, right? What goes on the first row here? Coefficients. 3. Drop it like it's hot. Huh? Oh, good job, Katie. I had that in my head to say, and then I didn't even do it. We need a placeholder for the 2. It would mess up everything. Katie definitely gets the star for today. All right, 4 times 3 would be 12. Remember, this is just a recap here. Add, multiply, add, multiply.
160.
I know, but I'm wondering.
I got you.
This is right. Yeah, keep going. What do you get?
Why did you subtract?
Why did you subtract it? Why'd you subtract it? Yeah, okay.
Gosh, I'm going to have to start this one over again. 660, this is 662. All right, interpret this answer for me.
The remainder is 662. The constant is 165. There's 40 x's, 10x squared.
Oh my goodness.
40x. Wait.
4
Never
times
mind. Never mind.
Plus 40x plus 165. And then it is plus 662 over x.
Okay. I want y'all to, okay, easy, right? Here's the first thing that I'm going to show you. This is what we call the remainder theorem. Do something for me. Take f of x, which is this,
Where's this? I can't
okay,
Oh.
and find f of 4 for me. Tell me what you get if you plug 4 in for f of x.
Take a wild guess and say it's the same.
In the top equation, this is f of x. I want you to find f of 4 for me. So if you're using the calculator, you could do
So, when we have
4 store is x,
when we start.
and then type the equation.
Is there anyone to star on that? No. Like
I'm sure.
when you divide it by. Oh wait, are we just doing that?
We're just doing this. So you are literally doing 3 times 4 to the 4th minus 2 times 4 to the 3rd. And tell me what you get.
666.
Oh,
Hold on, yo.
It's almost like that's the
Whoa. And that's also if you plug in what you divide or like the 4. Like because that's what it means.
oh, that's pretty cool, right?
So it's little exponents too. Because if you think about
That's correct.
So
So you're trying, okay, so look. Some of you are going, oh, wow. And some of you are going, what the crap just happened? Okay, here's what the crap just happened. If I have f of x, okay, and I divide it by x minus k, then f of k, which means I take this number and I plug it in for every x, will tell me what the remainder is going to be without actually dividing. You do. This is opposite sign. And I should have titled this.
What is k? It's a number. Well, it's a variable, but it stands for. Oh my god.
This is what we call the remainder theorem.
I feel like we're gonna figure out why this is okay.
You will. You will definitely find out in just a minute.
Is it get now how you code it to find F4? Are you gonna have to have to tell us what that is?
We'll just ask
It's the X.
It'll just ask you to find the remainder. Okay, so you can find the remainder one of two ways. You can do synthetic division, and you can find it at the end, or you can just plug in that K, and that will tell you what it is. So let's see. Let's try one more.
Wait, would it be plus or minus K?
No,
It'd be the opposite
no,
side.
opposite sign, opposite sign. Okay.
Was this on?
What about it? Yes, because you'll have to plug into that.
Theoretically,
But-
could you take the coefficient on the x and divide everything
Probably
by
just plug
it
into
to make
the
it synthetic?
No.
Okay.
I'm talking about like what you get after you do synthetic.
And what about it?
So we need that in our answer.
No, if you're talking about remainder theorem and you're just asking what is the remainder, all you need is the remainder. All right, let me show you one more. Let's see. If f of x is 3x cubed minus 6x squared plus x minus 11, what is the remainder when you divide by x minus 3? I'm going to show you both methods here.
We don't have to use both, do we?
Not on this one, nope.
I got the answer over X minus 3.
Uh-oh, where'd I go wrong? 9, 3, up.
When we get the
Yeah.
answer, do we have to put the answer over the fraction still?
No, because I'm just asking you what's the remainder. Okay, option B would be to find f of 3, which would be 19. Now, if I asked you this another way, what if I gave you the equation and I said, what is f of negative 1? Without plugging that in, what could you do? Without plugging in negative 1 for x, how could you find f of negative 1?
Turn everything negative.
So you're exactly right. Look, think about this. I'm getting you to think forwards and backwards through that theorem. Okay? If I'm not asking you for the remainder, we know that to find the remainder I can plug in. So then if I have here, then really what they're asking me is what's the remainder. And easier even than plugging in, I could just come here. I need a 4, 3, 2, 1, nope, 1, constant.
Is it supposed to be a positive one on that side?
It's already changed the sign when you plug it in. Okay, so I'm really trying to get you to think through both ways with this theorem. Negative 6, negative 5, 5, negative 5, negative 5. Nope, I had it right. Stacy. Right, so f of negative 1 is negative 6. Do you see what I'm doing here, how I'm using it both ways? Using that theorem to answer two different questions without actually plugging in. Knowing that when you plug in a number, really what you're finding, anytime you plug in, let's write that down. F of k is the remainder when you divide by x minus k.
How come when you plug it in, you get
You should get the same thing. Don't change the sign, keep the sign the same. All right. Now, let's take this a step further. Y'all ready?
The further we go, the more maybe it's easier.
I want you to divide this for me really quick and then we'll talk about it. I want you to divide all of this by x plus 3. Tell me what you get. Or so you can use synthetic since it's x plus 3. But divide it out and tell me what you get. Sure, you can. If you can ever do synthetic, do it. No, because I'm not asking for the remainder. I'm asking what you get when you divide it. I want you to divide it. What's different?
No remainder.
There's no remainder. This is very, very important. Tell me what you know if you divide something and you get no remainder. What does that mean? It goes in evenly. What do we call something that goes in evenly? A factor, right? If I did 6 divided by 3 equals 2. Because it goes in evenly with no remainder, that tells me that 3 is a factor. And what does it tell me about 2? It's also a factor, right? So these are both factors. Do we all agree? I know. It's been saying this for about a year and a half. Okay. This is just a side example with just numbers instead. So what this tells me, because I got no remainder here, then x plus 3 is a factor. What's the other factor? Now, we have done a lot of factoring, right? How can I rewrite yeah.
You know that it's 6 squared, so like 6.
Because this is whenever you label your columns in synthetic, this is your remainder constant x squared. If I had another column, that would be my cube column. So how can I rewrite f of x using my factors? Multiply them together, right? Think back over here to this little easy example where y'all said, where did that come from? I could say that 3 times 2 equals 6, right? When you divide, what you divide by times what you get is what you started with. So I could rewrite f of x as it would times x plus 3. Okay? Now look, did you know how to factor that?
No.
No, it doesn't group. I didn't know how to factor it. But if I have one factor, I can get it into a form that maybe I can factor it from there.
So another way to factor is to divide.
Exactly.
If it works.
Yes, exactly, exactly. So here's what the factor theorem says. The factor theorem is it's just what we just did. We worked out, and you came to it on your own, really, is what you did. If, let me title it, Factor Theorem. If, I'm going to use F, I'm not going to, your book uses P. if f of k equals 0, tell me what that means. We learned that from the remainder theorem. There's no remainder. So if there is no remainder when you divide, then x minus k is a factor. That is all the factor theorem says. Okay? Remainder theorem says you plug it in, you get 0. That means there's no remainder. Actually, it says you plug it in and whatever you get out is your remainder. Factor theorem says if you plug in and get 0, then x minus whatever you plugged in, that's your factor. Okay? Does that make sense? So synthetic division is going to be really, really handy as we plug things in, because we can plug in and just take that remainder is what we get whenever we plug in, right? So we're looking for things with 0 remainders is what we're looking for. And from there we can factor. So let's see. Let's first look at, if I have f of x equals x cubed minus 7x squared plus 7x plus 15, first thing I want to know is x minus 5 a factor? Yes or no? And why? How do you know? I don't know. What are you going to do? I mean, I do know, but I'm just getting you to. How do you tell if it's a factor? What tells us that it's a factor? No remainder. So you have to divide to see, is it a factor? Well, you can plug it in or divide. But here's the problem. I'm going to get you to do something else with it, so you might want to divide. Mm-hmm. Is it a factor? It is a factor because f of 5 equals 0, which tells me yes. By the remainder theorem, by the factor theorem, this is a factor. Write it in factored form now. Start with this.
You have to.
No, you can put it, doesn't matter the order. Factor completely. Is it? Is it factored completely?
They don't get it.
Oh, you can do the 3 and the 1. Wait, I didn't get 0 when I divided.
It might be a sign issue. Find it. So factor completely means take everything you have and factor down even more.
Yeah, I can factor in negative 3.
Now it's factored completely. So what I started with was this cubic that I absolutely could not factor on my own. But if they gave me a starting point and they gave me a factor, from there I can factor down and get it broken down completely. Yes, because the leading coefficient's 1.
And if it wasn't a factor, you would do a factor down.
Correct.
It was
Yes. Let's see if you really. What'd you say about 0?
Now you know all the zeros.
That is that's such an awesome, that's what I was fixing to get to. Good job. Now you know, did y'all hear what Ethan said? Now you know all the zeros of the function. So you know that this crosses at 5, 3, and negative 1. That's awesome. That's actually the next section. We're going to pick that up some too. Say again?
It's finally off.
Yeah, and because I did that and it's negative 3 and 1, because this leading coefficient is 1, these are just what goes in here. Let's do one more. Okay, you might not need this example. If you don't need it, that's okay. Oh, that's supposed to be.
I was like, why didn't you just combine them?
Sorry. I'm going to tell you that x plus 4 and x plus 3 are factors. And I want you to find all the remaining factors. I want you to factor completely.
Wait, what?
Say it like that.
Yeah. Well, like I said, your
Ominous.
challenge should your teacher accept.
Yes, this is your challenge.
Start.
So how do you even start? What do we do? What should we start with?
Divide by 1.
Let's start. Yep. Let's start with this factor. Okay. So I'm going to start with this one. And I have 1, 9, 23, 3, negative 36. I'm making all kinds of mathematical errors up here today. Y'all with me so far?
Yeah.
So at this point, I have x plus 4 times x cubed plus 5x squared plus 3x minus 9. Since this is a factor, I'm going to do this one using this portion though. Okay? I can't go, I need to know what multiplies with this, what multiplies with x plus 3 to get this one. If I just put 3 into the original one again, that's going to tell me what, there's going to be too much repeat there.
What if you did the 3 first?
Then you would do the 3 and then you would come back and do the 4 to what's left, okay? But you have to do it to whatever's left.
Okay, could you, hypothetically, for the second part of the last part, could you like do the switch thing and do them?
If they will group and you could do that.
So like if you switch the 3x and 5x squared, couldn't work. 5x squared, never mind.
Yeah, no, it won't group.
Wait, so what do we do with the x plus 3?
All right, so now I'm going to use that x plus 3.
You have to factor
Because here's what I know. I know that x plus 4, yes, we will, times x plus 3 times something gives me this. I've got the x plus 4 part, right? I need to take out the x plus 3 from this. So to take it out, I need to divide it. To find out. Then I should be down to a quadratic, which should be easy for me to factor. So I have 1, 5, 3, negative 9.
So you got a new number?
Yep. Always use those new numbers after you've done it one time. And it works, and I know it works because I got no remainder there, okay? So essentially, I'm ignoring the x plus 4 now, and I'm trying to break down the x cubed plus 5x squared plus 3x minus 9. And I did.
Okay, do you factor, if it's handy, do you factor the x to
If you can, yes. If you can, that would be easier than factoring through. But because they gave me 2 factors to start with, I need to use those 2 factors they gave me. That's exactly right. So we're always looking at what we have and we're trying to factor even more every single time. And we keep doing that until we absolutely positively cannot factor anymore.
So now we start. So we have
It should be your biggest exponent, your degree, should tell you how many zeros you end up with. Yeah.
What?
Would that be squared for this?
Yes, if you wanted to write this as x plus 4, x plus 3 squared, x minus 1, that's fine too.
Okay.
All right. Hopefully not too bad. Okay.